Shubhangi, let me know if you can see my screen.
Yeah, we can see it.
Okay, sure. Okay, so hello and welcome everyone to the second session of the cloud series. So I'm sure you must have thoroughly enjoyed the first session where Arjun Basu had covered the basics of cloud computing and demystified multiple jargons around cloud computing. So in today's session, I'll talk about the architecture of cloud computing and about the technologies which enables cloud computing. So in case you have any queries, please feel free to stop me in middle and ask questions. So I encourage everyone to keep this session as interactive. So let's go through what's in it for you. So for the benefit of the people who missed the first session, I'll start with a recap of the first session and cover the basics. So then I'll move to the today's topic, that is what's behind the clouds, where I'll cover the architecture of cloud computing, followed by the technologies that make cloud computing work. So then I'll deep dive into one of the most used technology called virtualization and see how virtualization works and what are the different types of virtualization and how it enables cloud computing. So in the end, I'll go through the main challenges of cloud computing and how you can contribute towards cloud computing. So cloud computing is a buzzword. Everyone knows it. Everyone must have heard it. And it is almost omnipresent everywhere. And there are multiple cloud computing applications and services which we use without even being aware that it is a cloud computing service. For example, Facebook, Twitter, Google Docs, Gmail, and many more. And I'm sure that you all must be using these services. And it will not be too much to say that that time is not too far when as a parent, we will be telling to our kids not to worry about the birds and bees in the cloud, instead to learn about the cloud computing. So it again gives you the importance of the cloud computing and how widespread it is. So let's understand what is cloud computing. So there are multiple definitions of cloud computing, and Arjun also has explained multiple definitions of cloud computing in the first session. So in simple words, if I want to put, so I can just say cloud computing is a combination of a software and hardware based computing resources delivered as services over the cloud, or in simple words, internet. So it can be server, it can be database or networking, software, analytics, and intelligence, and many more. So anything which is delivered using the internet. So I can also say that cloud computing means storing and accessing your data over the network. So also with cloud computing, you pay for what you use. You can scale up or down your applications as required. And applications are much easier to manage because you can manage it through the web interface. Provisioning is faster, and there are many more benefits being offered by cloud computing. So we will see that how these benefits are provided or achieved as we go into the details. And as you know, there are multiple organizations or companies which provide cloud computing services. So VMware is one, Google is there, Amazon is there, Oracle Cloud, Salesforce, Microsoft Azure, and many more. So let's go into the different types of cloud computing. So based on the deployment models, we can divide cloud computing into multiple types. And same way, based on the service models also, we can divide the cloud computing in multiple types. So first I'll start with the deployment models. So based on the deployment models, if I have to divide the cloud computing, I'll say it's can be divided into three types: public cloud, private cloud, and the hybrid cloud. So let's go through the public cloud first. So in case of public cloud, all hardware, software, and all other supporting infrastructure are owned and managed by the cloud service provider itself. And resources can be shared among different customers. So these are the resources which can be accessed by different customers. And since the resources are shared, the cost of renting a public cloud reduces. So there are multiple providers which provide again the public cloud. So Microsoft Azure is one, Amazon is the other one. So let's go to the second type now. It's a private cloud. So if you go by the private cloud, so cloud computing resources are used exclusively by a single business or organization. So in this case, resources can also be physically located in companies' on-prem data center. So all the resources are are there in the on-prem. So the customer has more control on the resources. And this, if you see, this kind of cloud is generally used by the financial organizations or the educational institutions. So it provides more security and more control over the resources. And cost-wise, it is costly as compared to the public cloud because the resources are dedicated to one customer. Now let's go to the hybrid cloud. So in case of hybrid cloud, public and private cloud both are used together, and it allows data and applications to be shared between them. So an organization can decide if they want that their critical applications or more secure applications can be hosted on the private cloud, and the other applications which need a scale or which are not much critical, those can be installed on the public cloud. So customers can choose the deployment model based on their strategy and the requirements. So VMware is one of the hybrid cloud provider. So after seeing the types of cloud computing based on the deployment models, let's go into the different types of cloud computing based on the service models. So here also we can see that there are mainly three categories. The first is the IaaS, the PaaS, and the SaaS. So IaaS stands for Infrastructure as a Service. So this is the basic category of cloud computing services. And in this case, cloud providers rent out the IT infrastructure, example, servers, their virtual machines, storage, networks to the customers. And customers are charged based on pay-as-you-go basis. So how much they use, on that basis, they can be charged. So if you want to see, the pizza as a service is a very famous example. So if you want to relate it with the pizza as a service example, so it is same as a community kitchen where infrastructure are provided to you and you cook your own pizza. And VMware has IaaS offerings as well. So some of the offerings are NSX, ESXi, vSAN. Now let's get into the second category, second type, that is a PaaS or a platform as a service. So it refers to the cloud computing service that supply the infrastructure and the runtime environment for the development, testing, delivery, and management of the software applications. So if you see, this is designed to make it easier for the developers so that they can concentrate on the developing the application instead of installing the infrastructure. So they need not worry about the setting up the infrastructure or management of the infrastructure. So they can directly go and start developing the applications which really matters to them. So in terms of, if I want to say that how I can relate it with infrastructure as a service, then PaaS is equivalent to IaaS plus OS and the runtime environment and tools. And if I relate with the pizza as a service example, then it is like some providers, the provider is providing you a takeaway pizza. So you have the infrastructure, you have the runtime and fire and everything, and then you cook they prepare the pizza based on the things you give them and deliver them, the takeaway pizza. So one of the example is Microsoft Azure for that. So that is a PaaS service. Now let's go to the third model or third type. That's a software as a service, or commonly we call it SaaS. And if you see, you must be hearing it SaaS everywhere. So every company is moving towards a SaaS. So in this case, software applications are delivered as a service over the internet, on demand and on a subscription basis. So SaaS is also related to the subscription. So when we call it SaaS, so we always relate to the subscription basis. So in SaaS model, cloud providers not only host and manage the software application, but also manage the underlying infrastructure and handle the maintenance part as well. So if some software upgrade is required, so service provider will only handle it. Some security vulnerability is reported on the infrastructure. So patching will be done by the service provider. So you don't have the headache of maintaining maintaining the infrastructure or handling the patching or upgrades. So the customer can put their efforts in the innovation or the business model or the business unique values which they want to provide to the customer. So in terms of PaaS, it becomes a PaaS plus the applications, software applications. Or in the pizza as a service example, you can say that full party is being organized by the event management team. You can enjoy and you can see that how you can make the party more fun-filled. So there are multiple examples for this SaaS model also. As Gmail is a SaaS offering, Carbon Black Cloud is a SaaS offering. So these are the multiple models or multiple types of cloud computing. So I'll pause here and I'll take if there are any questions, I can take those questions and then I can move to the next slide. Shubhajli, Pavitra.
So Neelam, we don't have anything on the chat, but folks, if you have any question, you can put it on the chat or you can either raise your hand. Yes, Shanmugha Priya. Priya, you have, please go ahead.
Hi, Neelam. I would like to know, like, I have heard about the term multi-cloud. How is this different from the hybrid cloud? I would like to know.
Yeah, hi Priya, an interesting question. So if you see when we talk about the multi-cloud, so now there are multiple cloud providers. So Microsoft has Azure, then Amazon has its own cloud. So multi-cloud means that application which can work on the all different clouds. And when we talk about the hybrid cloud, we generally take the public cloud and the private cloud. So it's both are related. So the public cloud can be provided by the different providers again. So it both are related, but that's how we relate it or we call it. So hybrid cloud, when we call it, we generally say that it's a mixture of the public cloud and the private cloud. When we say multi-cloud, then we take all the service providers together. So there's a nomenclature, but the boundaries are still merging now.
Okay, got it. Yeah. Thanks, Neil.
Yeah, no problem.
Yeah, Neelam, we'll keep it going.
Okay.
Yeah. So let's move to the next slide and the topic that what's behind the cloud. So it's I'll cover the cloud computing architecture here. So if you see the cloud computing architecture, mainly it can be divided into two parts, the front end and the back end. And the both of them, front end and the back end, interacts through the internet. So there's an internet in between, and through that they talk. So if I go through the front end, so front end is mainly to provide the applications or the interface that are required to access the cloud-based service. So client needs to access the service. For that, the interface will be the front end. So it can consist of the web browsers, means as Google Chrome or Internet Explorer, or any graphical user interface, or maybe CLI as well, a command line interface, which helps end users to access the application and to perform the required task. So that is the front end for you. Now, if I go to the backend, so backend refers to the cloud or the main infrastructure, which is used and managed by the service provider. It contains all the resources, the management of the resources, and also provides a security mechanism. So it includes storage, virtual applications, virtual machines, traffic control mechanisms, and deployment models, etc. So it's a combination. It has multiple components. So now let's go through these components one by one. So first becomes the application. So there's a first endpoint when a client accesses a service or application, then it comes here. So application is a software platform which client accesses and provides the service as per the client's requirement. So there's a one-line definition for this. Now on this backend, after the application, there's one more layer called service. So service is again the cloud-based service, and as we saw that it can be a SaaS, PaaS, or IaaS. So depending upon the requirement, it can be one of those. Now there comes a runtime cloud. So runtime cloud provides the execution in the runtime environment to the virtual machine. Okay, so after that, we need a storage as well. So storage provides a flexible and scalable storage service and also manage the stored data. Now, the last is the infrastructure. So cloud infrastructure refers to the hardware and software components of cloud, like servers will be there, network devices will be there, virtualization software, which is also called the hypervisor, will be there. So these are the main components. Now, if you see, there are different components, and to manage those components, you need a component called management component. So on the left-hand side, whatever you see the management, that is nothing but the management component, which manages all these components together. And now security is very critical piece of any software or any cloud. So this security will be providing you this multiple security mechanism for secure cloud resources, systems, and files infrastructure. So this is the full architecture of that. Or if I want to summarize it, I can say that there are mainly two parts, main components of cloud computing. So first is a front end and second is a back end. So front end is used to access the service, and the back end is where all the resources which are required to provide that service are there. Okay, so the back end is required to deliver the services to the user. So this is the architecture. I hope architecture is clear. So now let's move to the technologies which enables cloud computing. So there are multiple technologies which are working behind cloud computing. So and makes it flexible, reliable, and usable. So few of them are virtualization, service-oriented architecture, we call it a SOA, and the grid model. So in today's session, I'll cover the virtualization part. So this is the technology which is mostly used. So I'll be covering only the virtualization here. So virtualization is a technique which allows multiple organization or customers to share single physical instance of an application or resource among themselves. Or in simple terms, I can just say that it enables multiple and different operating systems and applications to run on one physical server or host. As in this diagram you're seeing, there is a one physical layer. Over that, there is a virtual infrastructure. So there will be a virtualization layer in middle, which abstracts the hardware and makes it a virtual infrastructure. And over that, we can see that multiple VMs are running. So virtualization is the technology which makes it happen, where multiple operating systems can run on the single physical hardware. So it gives you the logical boundary. We'll see that in more detail when we see that how virtualization works and why we need virtualization. So this is a virtualized cloud model. Now let's me go how virtualization works. So in this figure, you can see the traditional server architecture and the virtualized server architecture. So in traditional server architecture, or you say your laptop, so how it is you have a physical hardware, then you have an operating system, and on that you install the applications. But in virtualized server architecture, you have a physical hardware. Over that, you have virtualization layer, which abstracts the underlying hardware and emulates the hardware, or means this virtualization layer is also called as a hypervisor. So on this hypervisor, you can install multiple instances of the operating system. This operating systems can be different. So one instance can be of Linux, the other can be of Windows. So how those works is each instance is called the virtual machine, and those are encapsulated and secure. And those are independent instances. So each instance works as a separate machine. So now you can see that the one physical hardware can act as multiple machines here. Right. So, and one more thing for the virtualization layer is that this virtualization layer can be installed in two ways. One way is how you can see here, that it is installed directly on the physical hardware. So the other way is on the physical hardware, you have the host OS, because this physical hardware you call at a host, and you have an operating system, and on that you have a virtualization layer, and then you can have a multiple instances of the OS, which is called a guest OS. Right? So this way it becomes that there are two types of hypervisor. So type 1, we call it when the virtualization layer or hypervisor is directly installed on the physical hardware. So that is a type 1 hypervisor. And when there is a host OS and over that you install hypervisor, then it is called as a type 2 hypervisor. So some examples of type 1 and type 2 hypervisors are, in case of type 1, VMware ESXi is a type 1 hypervisor. Microsoft Hyper-V is a type 1 hypervisor. Type 2 hypervisor, if I want to give you the examples, it's a Microsoft Virtual PC, Oracle VirtualBox, and VMware also has an offering, VMware Workstation, VMware Fusion. So these are the type 1 and type 2 hypervisor. So both of them has its pros and cons. So if you see the type 1 hypervisor, because it's directly installed on the physical hardware, it has direct control or full control on the physical infrastructure. So the processing can be faster because there is no intermittent layer between that. But because it has to control the physical infrastructure, the functionality becomes complex. So that way means type 1 and type 2 both has its pros and cons, and depending upon your requirements, you can use either type 1 hypervisor or a type 2 hypervisor. Okay, I hope this virtualization is clear to you. Now let's see why we need virtualization. So for this means why we need virtualization, let's again go by example. So assume there's a company called XYZ, and which has three different applications. One is mail, the other one is web, the third one is a legacy applications. So if you go by the traditional way, you will need 3 servers, one for each application. And when you deploy this application, you observe that the utilization of the server is not more than the 30%. So you have deployed one service, one application on one server, but the resources are not utilized fully. So the utilization is very low. So what if you think that in one server itself, logically we can separate it out and create two servers out of it. Or the better ways means if we create 3 servers out of the one server. So, and we install all the 3 applications in one server. So this way the resources utilization can increase from 30 to 90%, right? If all the 3 can be installed on the one server, and you will save 2 servers, 2 extra servers, which can be used for installing the other applications, or maybe you can shut it down as of now if you don't need it. So at least the power usage will reduce. Right? So this way, where one server can be logically separated out into multiple servers, is nothing but it's a server virtualization. And from this use case, you must have known that what are the advantages of virtualization. So as we saw, the one very obvious advantage is resource efficiency. So all the resources are being used efficiently, and the server utilization increases. So and server count decreases, which means the cost also decreases. Now, because the server is installed only once, and you can, because that if you see the physical hardware host operating system hypervisor, this virtualization layer, everything gets installed when you have to just go and provision the application. The application provisioning becomes faster and easier. And one more property or feature of virtual the machine is that you can take the snapshot at any time and save it as a backup. So in case something goes down, or one server goes down, you can quickly restore that backup, and that application is up and running in quickly. So this way, it's the disaster recovery is easier and the downtime is also reduced. And because we are putting all the applications or multiple applications in one server, so this way the carbon footprint also increases. So we are giving back to the community again. And these are lightweight and can be used anywhere. So easier migration to the cloud. One more thing, I was explaining about the type 1 and type 2 hypervisor in the previous slide. So if in this case, if you see, there's a physical hardware down. Over that, there is a host operating system and then the hypervisor. So this means this is the type 2 hypervisor, which is being shown here. So this gives you the picture that why virtualization is required. So we know that how virtualization works and why virtualization is required. Now let's get into the different types of virtualization. Now, based on the entity which we are virtualizing, there are different types of virtualization. So first, we can see the server virtualization. So as we discussed initially also, where one server can act as multiple servers. So that is nothing but the server virtualization. So these are most commonly used virtualization. And in this case, virtual machines run on a single physical server. The CPU, memory, storage, and networking of the physical server are all shared among the VMs and provided through the hypervisor, the abstraction layer. Each VM is isolated from each one and another and runs independently of the other VMs on the same physical box. So there's some well-known providers of server virtualization at Hyper-V, Red Hat, vSphere, XenServer. So these are the kinds of server virtualization. Now let's get into the storage virtualization. So as the name suggests, so it virtualizes the storage. So in this case, the storage is abstracted. So in this case, multiple physical storage devices are grouped together and presented as a single storage array to the virtual machines. And servers that use the virtual storage system do not know exactly where their data is and work seamlessly. So this way we can have a storage virtualization. Now the next one is the network virtualization. So in this case, all the physical networking components are combined. So as you can see in this figure, that there's a Ethernet cards, so which are combined and into a single and software-defined layer platform that sits as an overlay on the physical network and provides a network connectivity to the virtual infrastructure. So here, there are the physical Ethernet cards. So there's a virtualization layer here. And if you see, every VM has a virtual Ethernet card. So these are nothing but the instances of the physical Ethernet card. Right? And whenever the VMs want to interact with each other, they need not go to the physical Ethernet card. So this virtual Ethernet, through virtual Ethernet card only, they can talk. And if they want to talk outside of this network, then only they should talk to the physical Ethernet card. And they will not know to whom they are talking. So it will be like, for them, it is the physical Ethernet card only they are talking with. So there are a few providers or a few examples for network virtualization also, that vSphere NSX is one, and the Cisco ACI is the other one. Now let's get into there are two more types of virtualization. The first is application virtualization and the desktop virtualization. So in case of application virtualization, applications are virtualized and are hosted on a server. And application functionality is delivered to end users' devices over the internet. For example, instead of logging to a computer to your office to access the application, you can directly access it from anywhere or any device, provided you have an internet connection. So you need an internet connection. Or easier way to understand it is that application virtualization is again a software as a service solution, or a SaaS solution. Now the last one is the desktop virtualization. So it is also called as OS virtualization or the VDIs. VDIs is virtual desktop interfaces. So in this case, the virtual desktop is stored on a remote and physical server, and it allows the user to access their desktop from any device or location. So to understand the use case of this VDI or desktop virtualization, you assume that 10 people have joined a company. Now, for them to start their work, they need the laptops and they need to access the company network or company specific applications. So now they have to wait for the IT team to configure their laptops and give them their laptops. And so instead of that, what IT team can do is they can create the employee specific VDIs or virtual desktops based on the application which are required by the employees and give them the access to those. And now these employees can access their VDIs from their personal laptops and start working. So this way, if you see the onboarding process time has reduced a lot, and employees can start working after 1 day, on the day one itself. So these are the use cases, if you want to relate this with the use cases as well. Now let's connect the dots. Means we have seen that basic how virtualization works, why we need virtualization, and now what are different types of virtualizations. So now you can imagine that how the software defined data center will look like. So in this figure, you can see there's a physical server, there's a physical storage, and the physical network. Right? So over that, the hypervisors or the abstraction layers is installed, which abstracts or virtualizes the below entity, the physical part, and provides this compute virtualization or the network virtualization or storage virtualization. Compute virtualization is nothing but the different name for the server virtualization. Now, on this, the virtualized layer, we can install multiple VMs. We can get the multiple virtual networks and virtual data stores. So these all things now can be managed with a management tool. So VMware has its offering called VMware Sphere Suite. So with that, you can monitor and manage the full data center. So this is the software defined data center, or you can call it as a cloud computing solution or a service. Now I will stop here. If you have any questions, let me know.
Yeah, Neelam, we have a couple of questions on the chat.
Yeah.
So yeah, is private cloud also provided by public cloud providers like Amazon and Google?
Private cloud, usually what they will do is they will give you the dedicated infrastructure. So in many a case, the customer itself has its on-prem data centers. So whether Amazon provides it, I need to check. I'm not very sure about the Amazon, because I know that they provide the public cloud.
Okay, so we have one more question. What kind of services Oracle providing?
Oracle provides a SaaS, means I give you the examples also, that they provide SaaS. You're talking about the IA SaaS or PaaS or the public cloud, private cloud, which service model or the deployment model?
Yeah, Beatrice, you can unmute yourself and you can ask Neelam directly. Okay, all right. Probably Neelam, we can cover a generic opinion on what kind of service they provide overall.
So they have a Oracle Cloud, so which they give. Okay, so Oracle Cloud will be the public cloud which they provide.
Okay.
So that's what I can say as of now.
Sure, yeah. So we had these two questions on the chat. So,
Hi.
Girit,
So I
go
have
ahead.
one question regarding mostly on the security aspect. Can I ask it now, or whether you'll be covering security part so that I can ask later?
Security, yeah, I'll cover that not in detail. So if you have any question, you can tell me now. Because I'll see
Okay,
if
just want to understand how we how we split CPU, network, and memory so that one host doesn't see the other host data.
So it's I mean, from the VM's perspective, you're talking, right?
Yeah.
Right. So
Yeah,
when the
from VM's
VMs,
perspective.
so now when you create a VM, you provide it as means how much CPU will be required, means how many vCPUs, how many memory will be required, how much memory will be required. So there will be a logical interface or encapsulation will be there. So one VM can't see the data for the other. So that way it is segregated. So logically, there's a partition between both.
Okay, I'm going to say is, let's say you have a 32 core instance and you have 4 VMs running on it, and would means while dedicating, would a VM be allocated a dedicated core, or on the fly would a VM be means moving from one core to other core, or means
So,
how are we?
So what I have seen is we can assign the vCPUs there. So when we are creating a VM, that time itself we can assign that how many vCPUs are required. So that will be dedicated to that VM now. Right. So 4 vCPUs are attached. Now you commission or you deploy one more VM, then next vCPUs can be attached. So those will be dedicated to that.
So likewise, so what you mean to say is means once we start an host means a VM, so it would have a dedicated CPU, and means that CPU is for it until it completes the operation. So
yes, or it's shut down. Yes.
And that would be the same case for main memory as well. So you would have a range of bank, and it would be assigned only in this range of bank, and it will not move to any other bank. Is that?
Yes, I think the technology is moving again. So there can be a dynamic thing also. So that because it is dedicated again, right? And see, if you're merging, then again, it becomes a security problem. So if something is written on this memory and both the VMs try to read that or write that, so that becomes a security problem. So in case of memory, so it should be dedicated again, right?
Neelam, I have a doubt related to this on-prem solution, right? So we call that private cloud, right? Now,
Yes.
whatever this VMware vSphere is there, right? This is like for maintaining on-prem cloud, or how is it?
The vSphere solution is for the ESX side. So if the customers are buying that infrastructure, then it becomes the on-prem again, right? So one ESXi server will be dedicated to that particular customer. But if you have, don't take that private cloud thing, then the same ESXi, we can create 2 tenants there. So that ESXi server is shared between both. So it becomes a public cloud.
Oh, okay.
Or a shared cloud, right? So that way. So it's like how much money you want to pay and what kind of service you want to take, right? If you want the dedicated infrastructure, again, the cost increases.
No, but my doubt is like, if he goes for Amazon and all, Amazon, they will maintain all the infra and all. But
Yes.
if they buy ESXi, who will maintain that ESXi, all that stuff? If 2 customers want to share,
Who buys? Amazon buys.
let's say 2 customers are there,
Correct.
and they want to share the infra. I mean, the virtualization infra, whatever is there that is provided by ESXi. Now, how can they do that? Actually, somebody has to maintain that infra, right? Virtualization infra.
Right. So the service provider is maintaining for you now, right? Because the customers are sharing, but who is maintaining is a service provider again. Right? So if VMware is providing a service, so VMware will maintain, right? Not the
VMware
customers.
will maintain. Okay. VMware will maintain. Okay. Sure. So now VMware provides like that also, I mean, it will share the resources for 2 customers, as you said, like maintaining ESX server and or set of ESX servers and sharing with the 2 customers. Now VMware does that.
Yes, so if you see, means the same applies for the BUs, means internal. Also, if you see, so we are internal customer to the VMware. So if I want my BU to have its own EXS server, so I'll become a one dedicated customer for it. So if I don't ask for the dedicated EXS, I'm ready to share it with some other customer. So it becomes a shared one then, right? So it is not the private or the on-prem.
Okay.
So the same applies to the external customers also.
Oh, okay. Oh, VMware. I mean, I'm saying not the not that like VMC on AWS, not that one. I'm saying. I mean, just basic one. That one is also I mean maintained by VMware.
The ESXi?
Yeah, ESXi, basic ESXi. Yeah. Or you are
Okay,
saying
that
about internal customers, right? I mean,
yes.
outside customers. For that also VMware shares something like that happens. That part I'm not clear.
I'll check that part because that will be again sales and marketing thing.
Oh,
so I'll
okay,
check that part and let you get you back.
Okay, but generally it's like whoever buy ESXi, that's for on-prem solution, right?
Yes, yes, because you are only
Oh.
maintaining the infrastructure now, right? So
Okay.
as you
Yeah,
see
yeah.
the EMC Square, right? EMC Square is the storage company again. So those people were managing this ESXi server or selling that. So if some customer wants to maintain, so they will buy the ESXi server from EMC Square and then they only manage. So it becomes an on-prem solution for them.
Okay, okay. Then using vSphere, this suite, they can maintain all that on-prem solution, right?
Yes.
Okay, sure. Thanks.
Neelam, we have one more question from Sundar. Is server virtualization also called as server consolidation?
Server consolidation.
Yeah.
Okay. I never heard about this term, server consolidation. So I need to check it. So Pavitra, maybe you can take a note with the questions
Sure,
which
sure.
I am not answering, then we can get back.
Definitely. Yeah.
Okay, I have another question, Neelam. So you were mentioning like the server virtualization where there are 3 server instances, and based on the resource utilization, 2 servers can be combined together as a single server, right? Okay, so how does that is being done? How is that done? Like through what tool? Is there any?
You're talking about this, right?
Yeah. So is there
Okay,
any tool which does that, or
no, it's again
should
the
we need to write any? Yeah.
So it's again the virtualization layer. So what I explained here also, see in this diagram, you can see that, right? There's a physical server, and over that you have a virtualization layer, which abstracts the physical hardware, right? So what it does is it emulates the hardware and provides it to the above applications. So each VM will get some physical hardware slot or physical subset of the physical hardware. So this virtualization layer is the one which provides that functionality. So the virtualization layer, or we call it the hypervisor layer or the abstraction layer. So this is the software virtualization, which provides you the logical segregation of the server. So it creates multiple servers out of one server.
Okay.
Did I answer?
Yeah, but how like in case of say you say one server is having some 35% usage and another server is having 20% usage. Now, in order to have a better utilization, can we have those 2 servers combined together and run as a single instance?
No, so that's not the case. So we are not combining the server. So maybe from there you brought that concept called server consolidation. So it's not that. So what you can do is one server, you can logically create multiple VMs out of it, and each VM now becomes a separate server for you, right? So it acts as a server physical machine for you. Right? So as of now, you have one laptop, right? So one physical machine. So now I can operate only one. Now you assume you have a big server or ESXi server, which we were talking about, or in this laptop also, you can have multiple OS, right? You install something called VirtualBox or some hypervisor virtualization software, which allows you to install 2 operating systems at the same time. Right. So this way, you can divide a server into the multiple servers. So in this case also, one server will be there, which will be divided into 3 servers now. So other 2 servers you can shut down. So you don't need 3 servers because all the resources are not utilized completely or fully.
Okay.
right? So that way I was telling you that one server can be logically divided into multiple, and you can install all the 3 applications on that server itself. So 2 servers now are redundant for you. You don't need them, or you can install some other applications on them.
Okay, fine, sure.
Did it clear?
Hi, Neelam.
Yeah. Thank you.
Hi, Neelam. Does VMware provide the service to migrate legacy servers, the legacy physical servers, into equivalent virtual servers?
Yes, I think there's some solution. Means I can get back to you on the name. I don't recall the name, but how to migrate from on-prem to the virtual machine, there's some solutions for that. Some tools are there.
Okay, thank you.
Any other questions now?
Yeah, Neelam, we are good to go. Proceed.
Sure. Okay. So now, as we know, that everything is not so rosy in this world. So we do have challenges of cloud computing also. So there are multiple, as we were talking about the security and privacy also. So security and privacy is the main challenge or the biggest challenge of cloud computing. So now your data is stored in the public cloud. So many customers are not ready to share, or they have that security constraint, or maybe that compliance policies where their data can't be stored in the server, which is located in some other geographic location. So that is also one more thing. So that's why you must have heard in the news that the data centers should be there in the India if we are storing some government data in the cloud. So these are the main issues now, security and privacy issues. So now for security, means that the cloud providers are coming up with the encryption or security hardware, security applications, so that they can make these services more secure. And there are multiple solutions coming up with that. Now, second solution is the interoperability. So one application is there, which the application on one platform should be able to incorporate services from the other platforms also. So one platform means the Linux. So the application is having a service from Linux server, Linux platform. So it should be able to interoperable with the other platforms as well. So there's the second challenge. Third challenge is the portability, as we were talking about the multi-cloud, or the cloud is provided by different providers. So now applications means when you buy a solution from one provider, then you should be able to port that application into other provider as well. So this is one more big challenge, where one cloud provider to another, the application should be migrated. And there should not be any vendor lock-in, because when you buy some application, you are not able to migrate, it means you are locked with that vendor. So this is one more challenge, big challenge. And computing performance. So now all the applications are becoming data intensive. So it needs a high network bandwidth, and which means high cost. And the next, the fifth challenge is the reliability and the availability. So the cloud systems, because all the applications are now running, if you see with the pandemic, the digital transformation have increased. So all the customers are moving towards the cloud. So reliability and availability is becoming more and more important. So the cloud infrastructure or cloud system should be robust, and they should be dependable, and it should not go down. So because all the critical business applications are running there. So these are the main challenges. Now, with this, I'll come to the end. And how can you contribute to cloud computing? So what are the jobs available from a cloud computing side, and what all things you can do? So there are multiple job roles. So cloud administrator is one, cloud architect is there, automation engineer, cloud consultant. So there are multiple. So if you see the cloud administrator, so these are the experts which manage the company's cloud presence in the infrastructure. So they develop, enforce, and update the policies for how employees and users can access the cloud services, and what are security protocols are used, what policy should be there, how to monitor. They monitor and ensure the uptime. So these are the work which are being done by the cloud administrators. Now, cloud architect. So these are the one who designs and implements a company's cloud computing strategies. They will come up that whether you need a public cloud, private cloud, or the hybrid cloud. So which kind of model you need. So everything is done by the cloud architect here. And they should also see that everything stays on track and on budget. So you should not be spending more. So when you decide about the model or which deployment model you choose, their cost is also involved. As we were talking, that private cloud is costly as compared to the public cloud. So you should see that you should not be over budget as well. Now, the Next is the automation engineer. So because everything should be automated, so cloud automation engineers are required to build, implement, and maintain the automation technologies. Now, next is cloud engineer. So these are the people who are responsible for the managerial aspects of the company's cloud strategies. They work with the architects and implements the strategies mainly. Cloud consultant. So these people should have the extensive knowledge of cloud technologies and guides the companies looking for cloud-based tools. So which tools they should be using. And they suggest that which is the best software and tools to meet companies' technical and budgetary needs. Now, security analyst, security is also one critical part of it. So you should be responsible for the integrity and security of the company's cloud presence. And last is the software engineer. I mean, there are multiple, so I have listed these. So cloud software engineers. So who are the programmers who create the cloud applications? They develop the cloud applications, and they're also responsible for upgrading, repairing, or maintaining the software they develop and the databases they operate. So these are multiple roles. Everything needs different skill sets, and the responsibility is also different. So you can choose what you want to become and where you want to go, and depending upon that, you can acquire that skill set. So then, if you Google it, you will get that what all skill sets are required and how you can become, what courses will help you to go to that role, and you can go there. So with this, I'll go to the references. So these are few references if you want to read about more virtualization. There are HOL labs also for VMware. So if you want to try something, you can try those labs as well for virtualization. And few very good tech talks or tutorials are there which you can go through and learn more about the virtualization. So any questions? That's it I had. So if there are any questions, I can take those up.
Yeah, folks, you can unmute yourself and ask your questions.
Neelam, I had one question. Yeah, please go ahead.
Please, okay, sure. Among those roles you mentioned there, only the last one, cloud software engineer, that is the only role, I mean, who does this all programming part, right? Remaining all like
Right.
different, okay.
You can search this also in Google. This information you'll get.
Oh, okay.
So if you want to know more about these roles, you can easily get that. So I just wanted to list it. There's not only the programming, there are other things also. We always think that we should be a programmer to get into the cloud, right? So cloud computing. So, but there are multiple roles which you can do.
Okay, sure.
So Neelam, one thing I wanted to ask, like we have a lot of college students also who have joined. So if they go like from the industry perspective from where you sit, so how good are these certificates in terms of getting recruited, or like what would you suggest if somebody is trying to move into the cloud field?
Because those are the those people are starting their careers. So I always say that basic knowledge should be there. So you should do the courses. There are multiple courses, free courses as well as paid also. So learn the basics and then jump. Right? Then try. Some certifications. VMware also gives some certification. Do some certification, because when you go for an interview, you should have something to show, because you don't have the on-hand experience. So then you should be able to show that I have done this certification and I have this knowledge, and gain that knowledge. Shubhanji, did I answer?
Yeah.
I have two questions related to the topic, but maybe not related to exactly what we covered. Since you're from VMware, maybe you're the right person to answer. So one is, right now there are big, hello, is it audible?
Yes. Yeah, Girdhar.
Yeah. So one is, right now there are bigger players like AWS, Google, or Azure who is there in the market, and for them there are, they have too many parts and availability zones and all those things. Let's say in one availability zone, there are too many customers and they are sitting in one part, and maybe they would have a scenario wherein there is one part which is running at 90% occupancy, but there is another part which is running at 30% occupancy. So does VMware has a solution wherein I can dynamically shift a particular VM from one pod to other pod on the fly?
Yes, so we do have the VM live migration. So where you can running VM itself can migrate to the other pod. So we call it a live migration.
So and means I'm baffled how you even do that. Means there is network stack involved and there are too many means instruction set
Yeah,
means there are too many things involved, right? And it means you have the product. You mean to say
correct.
that
So
there is
we do a V motion. We call it a V motion, where one VM can be shifted from the one pod to the other one. So now we can have it. We can shut down the VM and then migrate, right? So that is the easiest solution where nothing will fail. Now we do have the live migration. So there we have to check that what all things we migrate. So that details I can get you back again. But we do have the live migration also.
Okay, that's great. Means we were thinking on the line. We thought that this would be a serious solution which may be needed by the industry, but we thought maybe it's very difficult to do because there is network involved and there is CPU instructions involved.
Yes.
Yeah,
I agree, but you can search on the live migration for VMware, then you'll get that. Or if you want, I can send you some details over that. So, but we do have that. So
this
maybe it will not be again. Yeah. Okay.
Sorry.
Tell me.
You are telling something. I interrupted. Sorry for that.
Yeah. So see, whenever we say that live migration, or whenever we say that when we back up the data also, right? So data will not be, maybe some labs will be there. So where it will not be the current or up to date data, right? So there should be some missing pieces, but we can see that what all things in live migration we can migrate.
Okay. So when I mean shifting a pod from shifting one VM from one pod to other, what I generally visualize is transparently. Let's say there is an application server which is running on a Linux OS. I envision that AWS would live migrate my whole Linux OS from one pod to a different pod, and they would still hold my public IP and my existing TCP connections, and means whatever is happening on the OS, means everything intact.
Got it. Yeah, I mean that's why we call it live migration, anyways. Yeah, but the details I'll get you. Yeah, sure.
Okay. So this is my last question. So this is means I'm not sure whether you would have heard about cloud workers from Cloudflare. So that's an concept. Means Lambda is something which is being used by many people, and the serious problem with Lambda is its cold start time, because you are literally starting a OS, means a Docker instance still a kind of starting your own OS. So that takes a lot of time, maybe in seconds or milliseconds. So what Cloudflare does is instead of using Lambda, they have processes. So they do have they did solve all the security issues when you're just using multiple processes rather than using a Docker. So in Docker we have, since it's an OS, you take into the security easily. I mean, security is being guaranteed by the Docker, and since it's a separate OS, obviously you are fencing one Docker from other Docker. But when you're running two processes, maintaining security is very difficult. But they did achieve it, and that's going really great for Cloudflare. So I just want to understand, VMware is also having some product, or are they having some roadmap in building such a product in future?
No, I can't comment upon that as of now. Cloud search, you said. I mean, what is that? I'll just see that. What is that?
Cloudflare.
Cloudflare. Okay, I didn't
Cloudflare is
hear about
offering
it.
cloud workers.
Okay. I don't know about it, so maybe I'll read it about it. Yeah. Okay. Thanks, Girdhar, for that information.
Yeah. Neelam, we have one last question. So I'm in a training for Kubernetes for developers. How can Kubernetes help in my cloud journey?
Okay. So if you see now, as we were talking about the VMs, now VMs has the OS and its all dependencies, right? So, but it has other resources as well. So now the world is moving towards the Kubernetes or containerization. So now all the applications, when we say the cloud, the applications should be cloud native. We are slowly migrating towards the Kubernetes. So Kubernetes is for the containerization. So one is the Docker solution, then the other one is the Kubernetes. So Kubernetes or the microservices has become a basic skill set which is required for the cloud computing now. So after this virtualization, you will be moving toward the Kubernetes. So it will help you in the cloud computing. So you need that. So Kubernetes is one more technology which will be required for this.
Yes, I think that would have answered her question. So anyways, I think we're on time, Neelam. So thank you so much for your time, and thank you all for joining. Okay, one second.
Hey, sorry, I have one question, Neelam.
Yeah, sure, Priya, go ahead.
No, I'm a full stack developer, so I'd like to know or try. I'm planning to work on cloud computing. From where can I start? What would be the right path to get to know about the cloud computing, Neelam?
These are the basics which I started, and as I said, start with the tutorials. So if you see, there are multiple tutorials available. If you want, you can go through the references which I have given. Okay, so from there you can start and get the knowledge. Right? So virtualization will be the one. Then how VMs, virtual machines work. Then slowly move towards the microservices, containerization. Read about the Docker, Kubernetes. So this way you can start from the basics and go to the advanced. And there will be some courses which will give you the path also, that how you can go towards that. So Google it and you will get it. But just see that when you Google, you get multiple resources, right? So you should be accessing the right resource. Right. So maybe these references will help you. And they are HL labs that I was telling you.
Yeah.
So just make use of those.
Experience. Yeah. From your
voice is speaking.
experience at least, I just thought like I can get, from your experience, so I just thought like, I wanted to hear from you like how to, what would be the right path, because when we browse, we get lots of things, right? Like so each one is suggesting one different path to choose. So because there are lots of AWS, Azure, everything. So
don't go to the specifics.
Like, from where we can start and when we can land for proper.
Yeah, Shanmuga Priya, that's what I was telling you. Means don't go to the specifics. Don't go directly jump to the AWS. Start with the basics.
Okay.
Okay. Once you cover the basics, then it will be easier for you to go to the specifics. That how AWS works, how Azure works. So this will come later, but cover the basics first.
Okay.
That what is virtualization, what is cloud computing, how virtualization has enabled cloud computing. Now, why we are moving towards the containerization? What extra it gives is, if you compare the VMs or the OVAs, we were having the OVAs. So how it is different from the Kubernetes or the containers? Why we are moving towards containers? So that will give you the path. Then you go to the specifics.
Yeah, sure thing. Thank you so much.
Yeah, no problem.
Okay, guys, any further questions? I think we have already crossed our time, but still we have Neelam here. So if you have any questions, feel free to ask, or you can email us at chennai@womenwhocode.com, and we would get back with Neelam's response on the same.
Right.
Yeah. All right. I think it was a pretty good session, Neelam. Thank you so much for your time. And I think you completely justified, and we all went behind the clouds and we saw what is there in it. So thank you so much for that, Neelam. And thank you everyone for joining. It was a really, an interactive session as it meant. Yeah. Thank you all. See you in the next session.
Thank you. Thanks, everyone. Bye-bye.
Thank you. Bye.
Thank you all.